it's still just a study of finding derivatives, integrals, limits, but you're using multivariable functions. It's actually a really young branch of math compared to a lot of other ones, like further into calculus. But you can see smaller parts in it, or smaller parts and ideas in older works. Like Leibniz, he was really eager to start it, but he didn't really get too deep into actual vector analysis. You can see it in the Mechanics of Heron of Alexandria, and it's also in Newton's book. It was like really actually started in the 19th and the 20th century, but it started as a geometric representation and using complex numbers. So one of the most important people that contributed to it was William Hamilton, and this was, or when he discovered quaternions, and this is the form that he wrote up for a complex number. You can see it's just a plus xi plus yj plus zk, where a, x, y, and z are all real, and the I, j, k numbers are all imaginary. He was the first person to give the vector and scalar names to the real and the different imaginary parts of his form. Another big name was Hermann Grossman. His first work, I can't say that, it expanded the vectors from out of 2 or 3 dimensions up to n dimensions. And he worked with modern matrices and into vector analysis. A lot of his work was abstract, and because he was just a high school teacher, a lot of his work just got ignored, and they didn't really even pay attention to the work that he was actually doing. So vector analysis, it just solves like it says, a very wide range of geometric problems. It begins with vectors, but you end up putting it into integrals and getting derivatives. This is the easiest for me to understand, like the way that you denote it. So this is just your different vectors with imaginary parts. You can manipulate them with scalars, and you can find the magnitude. That's just a quick little formula. And there's 2 ways that you can actually multiply the vectors, and this is the dot product and the cross product. And they do the same thing. They come up to the same number, but you do them different ways. You expand that, and you cross multiply those, and you cross up, and you subtract, like when you're going up, and then you just add them all up, and it gives you the magnitude. So to find the derivative, the actual calculus part of this is right here. These are the like formulas, like the basic formulas, and like there's a lot of different things you can do to find it, or to that these help you find. To find the gradient, and that's just where the vector is increasing the fastest from one point to another. That's that one. These are just different formulas you can use to find divergence, the curvature, and the curl, like if it's how fast it's rotating around the spiral. And that website's just like with the other like tips, it just gives you like a full-on list of formulas and stuff you can use when you're doing your vector calculus.
Okay, so then another analytical field is differential equations, and obviously differential equations is directly